Well, we're continuing to get used to special angles like pi over 6 and pi over 3 and converting them immediately without thought. But for weirder angles, you basically have to just use the conversion ratio, pi radians to 180 degrees. So for example, if I'm starting with degrees, I need to kill off radians.
Kill off degrees.
10 goes into the numerator. 10 pi over 180 is pi over 18. If I'm trying to get degrees, then I put the degrees on top. Normally the pi's cancel, and you'll then have 180 over 5, 36 degrees. 75 pi over 180 is 5 pi over 12. Calculator note, if you type in 75 divided by 180 and then math enter, it turns it back into a reduced fraction for you. When I was saying pi normally cancels, what I was thinking about is a problem like this. This must be 4 radians because it doesn't have a degrees sign. That's why you're supposed to be careful about writing the degrees sign all the time. It must be radians, and it's a weird number of radians, so it's going to turn into a weird number of degrees. So multiply by 180 over pi, you just end up with 720 over pi. Negative 12 degrees, back to normalness. Math enter, 1/15. Don't type the pi in when you're trying to convert to fraction, because it doesn't know from fractions with pi. So just type in 12 over 180, and it gives you 1/15, and then put the pi in yourself. 3 pi over 7, small cute fact, 180 is divisible by every number from 1 to 10 except 7. So because 7 doesn't cancel, you're going to end up with just 3 times 180 on the top. And one thing to notice, I wasn't being very good at 4 radians. Technically, again, it's radians unless you put the degrees sign in, so make sure you put the degrees sign. All right, right angle work. Draw the right angle in. Labeling conventions. I always put the right angle on the bottom right corner. You're free to do what you will, but it says C is the right angle. On all of these problems, C will then be 90 degrees. We're going to look soon at what happens if you don't have a right triangle. How do you figure out the sides? You still can. Okay. A is 40 degrees. The convention is that the side is across from the angle with the same letter. Put that in to my little list of answers. You can find angle B. These two are complementary. They add up to 180. Okay, B is, let's see. To find B, side B, and side C, I'm going to look and say 12.5 is opposite, B is adjacent, I'm going to use tangent. And I know you all were really good at this the other day in class, so I'm just going to say solve for B. And I'm going to say, I always put 3 digits. You can put at least 1 digit past the decimal point so that we know it's not a whole number. Unless it's something like 0.999, and then you can round up. For C, notice 12.5 is still opposite and C is hypotenuse, so I'm going to use sine. Pretty straightforward. Okay. Similar problem, if A is 28, but you know C this time, put in the numbers that we know. Angle C is 90 degrees, because that's what the directions say. Subtract from 90 to get the other angle. And set up two trig functions to find A. A is opposite, 19 is the hypotenuse. So I'm going to go for sine. For B, B is adjacent. Sine is not going to use adjacent. We want cosine. A little calculator fiddling, and we're done with that. Okay, two slightly different types of triangles. If you're not given the angle specifically, except of course for C, A is 3, B is 4. If you're given two sides of a right triangle, you use the Pythagorean theorem. So remember, subtract if you know the hypotenuse. How many homeworks have I graded already where people were adding to the hypotenuse? Don't do that. But this one, we're looking for the hypotenuse, so we are going to do it. Square root of 25 is 5. This is the classic 3, 4, 5 triangle. No problem. To find the angle, notice that 3 is opposite, 4 is adjacent. We use tan. Oh, tan of what? Tan of the angle. How do you solve for an angle? We want to do second tan. Calculator says, don't forget to be in degrees this whole problem set. Mode. Okay. And then subtract from 90. Incidentally, fast trick. If you subtract 90 and ignore the minus, you get the same answer, right? Okay. This last one is the trickiest one. Pay special attention. If I draw, sine B is 5/7, but B isn't 5. What's going on there? The idea is, if you're given a trig answer, it's a proportionality statement. It's not a statement of exact values. So what we have to do is set up a proportionality statement of our own using two different triangles. So we can say on the left, 7 is to 5, as on the right, C is to 8. Cross multiply, and we get what side C is. I think that's 11.2. B is already 8, and you get A with the Pythag theorem. Again, since C is the hypotenuse, do not add to it. Thank you. So B, oops, did I just write B as B? I wrote B as B. Hold on. B is 8. So do not add to the hypotenuse. Subtract from the hypotenuse squared. Okay. Incidentally, larger angle, larger side. C should be the biggest side in all of these problems. If you're getting a side that's bigger than your hypotenuse, you have trouble. How do you find either of these angles? Well, they gave you a trig function. They said sine B, when I say they, I mean me, is 5/7. So you should be able to just do second sine. Okay, and that's a little squishy, but I wanted to write all the explanations down.